Imagine a world so alien, so profoundly different from our own, that every discovery rewrites the textbooks of life. This is not some distant exoplanet, but the deep ocean, Earth's last great wilderness, a realm of crushing pressure, eternal darkness, and breathtaking, often bizarre, biodiversity. For centuries, it remained largely beyond our reach, a mysterious abyss, a frontier that promised endless wonders. But now, humanity stands on the precipice of a new industrial revolution, one that threatens to plunge into this untouched realm, deep-sea mining. Are we about to destroy the very last pristine ecosystem on our planet before we even fully understand it? This isn't just a question of resources versus environment, it's a profound ethical dilemma about our future, our planet, and the very definition of progress. Beneath the waves, beyond the reach of sunlight, lies an extraordinary tapestry of life, evolved under conditions unimaginable to us. Here, vibrant hydrothermal vents spew superheated, mineral-rich water, fostering oases of chemosynthetic life, communities thriving not on light, but on chemical energy. Giant tube worms, yeti crabs, and strange, eyeless fish populate these bizarre landscapes. Further afield, vast abyssal plains, once thought barren, teem with microscopic life, ancient glass sponges, and slow-moving sea cucumbers, their ecosystems delicately balanced over millennia. Seamounts, underwater mountains, act as biodiversity hotspots, their slopes home to unique corals and sponges that provide critical habitat for countless species. These deep-sea environments are characterized by slow growth rates, extreme longevity, and a high degree of endemism, meaning many species are found nowhere else on Earth. A single disturbance here isn't just a setback, it could be an extinction event, a permanent loss for science, and for the planet. We're talking about ecosystems that operate on geological timescales, where recovery might take thousands, if not millions, of years. So, why are we even considering venturing into such a fragile, mysterious world? The answer, proponents argue, lies in our insatiable demand for critical minerals. As the world transitions towards a green economy, powered by electric vehicles, wind turbines, and solar panels, the need for cobalt, nickel, copper, and manganese is skyrocketing. These metals are essential components of high-capacity batteries and advanced electronics. On the deep seafloor, these very minerals are found in rich concentrations, often in the form of polymetallic nodules, potato-sized rocks scattered across abyssal plains, or massive sulfide deposits around hydrothermal vents, and ferromanganese crusts on seamounts. The argument is compelling. Land-based mining often comes with significant social and environmental costs, including deforestation, water pollution, and human rights issues. Deep-sea mining, some suggest, could offer a more sustainable, or at least a less impactful, alternative to terrestrial extraction, supplying the critical materials needed to combat climate change itself. It sounds almost paradoxical, doesn't it? Destroying an ecosystem to save the planet. But the promise of a greener future through deep-sea mining comes with a terrifying, largely unknown price tag. The proposed methods involve massive, tractor-like machines crawling across the seafloor, vacuuming up nodules or grinding down sulfide deposits. This process doesn't just remove the target minerals, it obliterates entire habitats. Sediment plumes, churned up by the mining vehicles, can spread for hundreds of kilometers, suffocating filter feeders, blocking light to bioluminescent creatures, and altering water chemistry. Noise pollution from the machinery and support vessels can disrupt communication and migration patterns of marine mammals and fish across vast distances. And then there's the issue of waste. Processed material, often containing toxic elements, would be discharged back into the ocean, potentially creating persistent plumes of fine particles. Crucially, we know alarmingly little about the vast majority of deep-sea species and their ecological roles. Scientists estimate that up to 90% of deep-sea life remains undiscovered. To mine these areas now is to risk extinguishing species we haven't even named, erasing entire lineages before they've had a chance to be understood. This isn't just environmental impact, it's a planetary gamble of unprecedented scale. The regulatory framework for deep-sea mining is as murky as the abyssal waters themselves. Much of the deep seabed lies beyond national jurisdictions, making it the common heritage of humankind. The International Seabed Authority, or ISA, established under the UN Convention on the Law of the Sea, is tasked with both regulating mining and ensuring the protection of the marine environment. This dual mandate presents an inherent conflict of interest. As of now, the ISA has granted exploration contracts covering an area larger than Western Europe, yet a comprehensive exploitation code, the rules for actual mining, is still being debated, despite pressure from some nations and companies to fast-track permits. The scientific community is largely united in calling for a moratorium, a pause, citing insufficient data and the potential for irreversible damage. This isn't just about technical regulations, it's about a fundamental ethical question: do we have the right to exploit these last pristine frontiers, especially when the long-term consequences are so profoundly uncertain? What does common heritage truly mean if we destroy it for short-term gains? Here's where the narrative takes a surprising turn. While the demand for critical minerals is real, the urgency for deep-sea mining might be overstated, or at least misdirected. Many experts argue that a circular economy approach, prioritizing recycling, reusing, and designing products for longevity, could significantly reduce our reliance on virgin materials, both terrestrial and deep-sea. For instance, the metals in our discarded electronics represent an urban mine that is largely untapped. Furthermore, advancements in materials science are constantly seeking alternatives and more efficient uses of existing resources. The true surprise isn't that deep-sea mining is difficult or dangerous, it's that we might not need it, at least not at the scale being projected, if we fundamentally shift our relationship with consumption. The deeper mystery isn't just what creatures lurk in the abyss, but what kind of future we truly want for our planet. Is it a future where every resource, no matter how remote or fragile its source, is fair game? Or one where innovation, conservation, and mindful consumption guide our progress? The deep ocean isn't just a source of minerals, it's a vital part of Earth's life support system, a massive carbon sink, and a genetic library of unparalleled complexity. Its true value might lie not in what we can extract, but in its undisturbed existence. The choice is ours to make, right now. Do we rush into the deep, driven by immediate need, or do we pause, reflect, and innovate towards a truly sustainable future? The deep ocean holds secrets yet untold, and perhaps, the key to understanding life itself. Let's not silence its mysteries before we've had a chance to listen. What are your thoughts on deep-sea mining? Should we explore alternatives first? Let us know in the comments below, and don't forget to like this video and subscribe for more deep ocean mysteries.